Hello everyone, welcome back to my channel. Today's video will be on y equals to x power half. I will discuss the graph of this function as well as the properties of this function. So let us now start the video. So here we have the function y equals to x power half. So we will start with the function y square equals to x. So it is a parabola. So first we need to understand what are its properties. So this one is a parabola of the form y square equals to 4ax. So previously we learned about the parabola of the form x square equals to 4ay and it had the form this or this. Okay, so now we are going to the reverse direction where the axis of the parabola is this x-axis. So this a is used to find out the focus and lattice rectum of the parabola. So here this parabola, this y square equals to 4ax has the focus a0. So the focus lies somewhere like here. This is a0 and the length of lattice rectum is 4a, which is this one. The perpendicular line that passes through the focus. So length of lattice rectum is 4 mod a. If a is positive, then we get one form, and if a is negative, we get another form. So for positive a, what we have? We have 4ax positive for x greater than 0. So here we have this side of the parabola, and for a less than 0 we have this side. This is the left hand side of the y-axis and this one was the right hand side of the y-axis. Okay, so from this parabola we get this. If we take the root from both sides, so we will get y equals to plus minus 2 root a root x. Now this plus 1 corresponds to the upper side and this minus 1 corresponds to the lower side of the parabola. So it is obvious because this side is the positive side and this side is the negative side. So this side should correspond to the part 2 root a root x and this side should correspond to the part minus 2 root x root a root x. Okay, so here we have this relation. So now we are going to delve into the particular form of parabola, which is y square equals to x. So for y square equals to x, here we can write it as 4 into 1 by 4 into x. So if we compare it with 4ax form, then we will get a equals to 1 by 4. So from a equals to 1 by 4, we will get the focus at 1 by 4 0 and the lattice rectum as 4a, which is 1. So as this one is the positive side, as here the a here is 1 by 4, which is positive, so we will get the right hand side parabola. So this one here, so this point should be a0, this point, and the perpendicular straight line that passes through this point, this is the lattice rectum of the parabola. And here the length is, its length is 4a, that means 4 into 1 by 4, and this gives this 1. Okay. Now from this parabola we get, so from y square equals to x, if we take square root on both sides, we will get y equals to plus minus root x. And so here we want to plot the function of y equals to x power half. So we need to take the positive side. So positive side means y greater than 0 sides. So we will get only the positive part of the parabola, which is this one. So we have already plotted the parabola and from there we have plotted this function, the required function, which is y equals to x power half. Now let us come to the properties of this parabola y equals to x power half. So obviously it is an algebraic function, and moreover it is an irrational function, as x power half, x power 1 by 3, these kinds of functions are called the irrational functions. Next is domain and range. So here we can see that the domain is 0 to infinity as well as the range is 0 to infinity. So from the graph it is obvious, as the parabola lies in the positive direction of the x-axis, and here again parabola lies on the positive direction of y-axis. So from here we are getting that the curve lies solely on the x greater than 0, y greater than 0 part, which is the first quadrant. So these are the domain and range. Okay, so it is an increasing function. So it is obvious from the graph that it is an increasing function. So we need to prove that. So for proving, we can see that we have the function fx as x power half. So if we take the derivative, that will give f dash x half x power half minus 1. So it will give half x power minus half. So that means 1 by 2 root x. Now the root of any number or any quantity is always positive, as the square root function is always positive. So this is always positive. So the derivative is always positive. That indicates that the function is increasing. It is a concave function. So again, from the graph it is obvious that this function is concave function. So we need to again prove that, and for proving that we will use again the derivative, and for proving the concavity or convexity we need to find out the second order derivative. So second order derivative, so we have already obtained the first order derivative here. From there we can obtain the second order derivative. So second order derivative will give f double dash x, that means ddx of half into x power minus half. So if we do the derivative, we will get half into minus half into x power minus half minus 1. So it will give minus 1 by 4 into x power minus 3 by 2. Okay. So that means it is, okay, let me write it here, minus 1 by 4, 1 by x power 3 by 2. Okay. So as the function always lie in the positive direction of x-axis, the x must be positive. So that means this term, this x power 3 by 2 is always positive. So it will give that this whole term is negative. So this whole term is negative. So as if double dash x is less than 0, that means the function is a concave function. Okay, so let me highlight it, highlight the previous thing. Okay, now next, it is neither an odd nor an even function. So again, if we see the graph of this function, so for even function what we get, that function must be symmetric with respect to the y-axis. So it doesn't have that property. And for the odd function, we know from the graph that it must be symmetric about the opposite quadrant. So if this graph lies here, there must be something symmetric in the third quadrant, but that is not the case here. So again, from the graph we can conclude that the function is neither even nor odd. So again, if we try to prove it, it will not give anything. So suppose fx equals to x power half, And for finding out whether the function is even and odd, we need to take the minus. It will give this. So minus x power half, but it is not even defined. The minus x power half is not even defined, as for this function fx, the domain is x greater than 0. So it will give minus x less than 0. So that means minus x power half is not defined. So f of minus x is not even defined, so we cannot conclude whether the function is even or odd. It is neither even and nor odd. It is continuous in 0 to infinity. So obviously this function here is continuous in its domain. Okay, so it can be continuously drawn. So for proving that, we need to find out the limit at an arbitrary point. So let me do that. So limit x tends to a, fx must be equals to f0. So what we have here? Here we have limit x tends to a, x power half, and here we have a power half. Okay, so that must be if a. So a power half. So this is 2, right? So left hand side equals to right hand side for any a in its domain. So a must belong to 0 to infinity. So obviously this function is continuous in its domain. And also we need to understand one thing, is that when we are considering the limit at 0, so let me do it more clearly. So here a must be this, and for a equals to 0, we only need to consider the a plus 0 plus limit, as the function is not defined for the 0 minus case. So here we have this must hold, and this obviously holds. Next, it is differentiable in the interval 0 to infinity. So we can understand there is a problem at 0, and obviously from the graph it is evident that here, so here at the 0 point, we can draw multiple tangents. So that the function is not differentiable at x equals to 0. So let me first prove it. So let me take a number a, and we need to see that x tends to a, x power, this is fx, this is fa, and this is x minus a. So here we can see that limit x tends to a, x root a, and the bottom part can be factored into root a, again root x minus root a. So as x tends to a, so x not equals to a, so we can cancel out these two, and we will get that limit x tends to a, 1 by root x plus root a, it will give 1 by 2 root a. Now let us see what is the problem for x equals to 0. So for x equals to 0, here we have taken a belongs to 0 to infinity. So for x equals to 0, what will happen? Everything will go similarly, and here we can see that if we put 0 here, 0 here, then it will give something like limit x tends to 0, 1 by root x, and this is undefined. This limit does not exist. So the function is not differentiable at x equals to 0. Next, it has no local extremum, so it is obvious from the derivative, as we have observed that the derivative is 1 by 2 root x, and so it is not equals to 0, so it has no local extremum. Extremum in the sense that it so I should say that it has no local maximum. Local maximum. But as this function is an increasing function, it has minimum at x equals to 0. So as the function is increasing and the domain of the function is 0 to infinity, so it must have the minimum value at x equals to 0. So there is no need to find out the derivative at that point. As the derivative does not exist at that point, we cannot conclude it from the derivative itself. So the function x power half has the minimum at the point x equals to 0. In the next video, I'll be discussing about the function x power 1 by 3, that is an inverse function to y equals to x cube function, the cubic function, and I'll be discussing more videos, more functions in the later videos. Thank you for watching this video. Please like and comment on this video and subscribe to my YouTube channel and share this video with others for more graphs of function. Thank you.